Hello everyone, welcome back to my channel. So this is about ABCD parameters, okay? How to derive ABCD parameters when a T-type model is given, okay? So this comes under Power Systems 2, Unit 1, Performance of Lines, and one of the subscriber, someone asked me in the comments to explain about ABCD parameters, okay? So I'll just make it as simple as possible, okay? Please check till the end so that it's clear for you to understand. All right, okay, let's start. So this ABCD constants, this is nothing but these are called as transmission line parameters. Okay, first point is ABCD are transmission line parameters. Okay, so these are also called circuit parameters. These are also called cascade parameters as well, or cascade parameters also. Okay, so generally these ABCD parameters are used in like two or more networks. If any two networks are connected in cascade connection, then you can use this ABCD parameters. Okay, so this one of the advantage way this is useful is like you have to say it is useful in circle diagrams. You have you'll be knowing about this, what is power circle diagrams and all in this chapter in depth. Okay, this is the next topic of it. So there also we'll be using this ABCD parameters. So generally, if anyone will ask you where do we use this ABCD parameters, you have to say that it is used when there is any two circuits. If they are cascaded in connection, then you can use this ABCD parameters in power circle diagrams and all. And also, see, we will be sending in this transmission lines and all, there will be sending in voltage, okay, and receiving end voltage, right? In order to maintain the voltage values from the sending end to receiving end, almost the same value should be reached here, no, without any losses. To maintain that also, we will be using this ABCD parameters. Like we can cascade few networks and we can transfer that voltage. Okay, for that also we will be using this one. Okay, just a brief one. So generally we have like short transmission line, medium transmission and long transmission lines, right? So this ABCD, it is used, and this is one important point, in medium lines, transmission lines. Okay, that medium means 80 to 250 kilometers range. Okay, and their operating voltage will be 20 kilovolts. Okay, because the operating voltage is more and there should be no losses, we will be using capacitance in these circuits. Remember this point, capacitance is used. Like I said, it is a T model. All right, T means the shape will be something like this. And I'm also telling you there should be a capacitance. So obviously capacitance will be here in between this. Okay, so just a rough idea. I'll just draw and show you clearly how you should draw. So obviously when there's a capacitance, you'll be also having like the resistor and the reactance is also will be present. All right, so if I draw the circuit, see, resistor, reactance, and the capacitance is in the middle. All right, see, my diagram is not that perfect. Just for your understanding, I am just drawing somehow. Please bear with it. This is the load. Okay, so something it will be like this, and this will be the sending end voltage. You have to remember these circuits. All right, so see, this is the capacitor C. Let's start with this first loop. Okay, see, this is like a T network. No, that's what I mentioned over here. Now this is, there are two resistances here. So we will take it as R by 2, R by 2. Half the each side. Okay, this one will be X by 2, X by 2. So R and X, this both will become impedance. This is Z by 2. This is also Z by 2. Resistance and reactance, both combination will be impedance. Alright, this is there. Next, this is the sending end voltage. Obviously, this will be the sending end current. Okay, this current will reach here also. This will be IS. Alright, and here towards the capacitor, if it is coming, let's take it as IC, current towards the capacitor. And here this will be the receiving end voltage IR. Okay, this is that side. So the voltage across this point, I mean exactly this point to this point, that will be VR. From this point to, I mean here, after the reactance, this voltage across the load will be taken as receiving end voltage, that is VR. Alright, I hope this is clear. This is basic thing which you have to remember. And the voltage across this capacitor, let's consider this as V1. Okay, if you are clear with this one, okay, you can derive this expression very easily. This is loop 1, this is loop 2. Alright, please draw along with me. I think now when you have seen once, you might have understood. And draw along with me, repeat it one more time. And then we will derive the expression. Do it along with me so that it will be useful to you. You can understand step by step. Once this is clear, let's go to the next step. Okay. So now we will apply KVL in the first loop. Okay. So here see, KVL means the sending end voltage is VS. V is equal to IR, basic KVL. Okay. So VS here. I is this one, IS into this whole thing I am taking as Z by 2. IS into Z by 2 plus this one. This is there, no? For loop 1. Alright. In loop 2, it will be V1 is equal to, this is IR Z by 2 plus VR. Okay. Because here the receiving end voltage is IR, right? So IR Z by 2 and this will be VR. Okay, I'll just write here. Yeah, I just kept this paper because this will be useful in the next one. So apply KVL in loop 1. Alright, so you will get it as VS is equal to IS Z by 2 plus V1. Consider this as equation 1. Okay. This is Z, okay, so you just understand. Z by 2 plus V1. Alright, so this is equation 1. I'll just continue over here. Next is apply KVL to loop 2. So in loop 2, that is V1 is equal to IRZ by 2 plus VR. So I'll just write here. That is V1 is equal to VR plus IR Z by 2. Consider this as equation 2. See, this is one node here, okay? Okay, 2 points, 2 branches, they are joining at one point, consider it as some node, okay? At node A, okay, if you apply KCL over here, that means incoming currents is equal to outgoing currents. So see, incoming is IS over here. IS is nothing but it is equal to IC and IR. Incoming is equal to outgoing. This both are out, no? So I'll just write here. Applying KVL at node A. So that will be IS is equal to IC plus IR. Alright, from this you can also write IC is equal to IS minus IR. Consider this as equation 3. I hope this is clear, right? Now, this is basic thing. Just applied KVL and KCL. Sorry, this is KCL. Current, okay? KCL. Now you have got this, right? Now see, by Ohm's law, you can write, see, IC over here. In the circuit diagram, IC is nothing but V1, okay, V1 into here, okay, I did not write anything, so consider this whole thing is as Y, okay, so this IC is V1 into Y, okay, this whole part we are just considering it as Y, okay, so I will write here by Ohm's law, that is IC, current towards the capacitor is V1 into Y. Alright, so this is, I consider this as equation 4. Now what you do is substitute equation 2 in equation 4. Like, see, here we have V1, right? This V1 and this V1, you have to just substitute, this V1 and this V1 substitute over here. Alright, so that will be okay, I thought of zooming, it's not zooming. Okay, I'll just write it. So IC is equal to VR plus IR Z by 2 into Y. Okay, I just substituted the whole thing over here. Okay, consider this as equation 5 now. Okay, now we will see this whole term is into Y. Okay, this V1 we got from that one. Okay, now substitute equation 3 in equation 5. What is the equation 3 here? IC is IS minus IR. Here IC is there. So you can equate these two. Okay, so you can write it as IS minus IR is equal to this one, VR plus IR Z by 2 into whole thing into Y. You can otherwise multiply and write. I'll just continue next page. So that will be, I'll write again, IS minus IR is equal to YVR multiplying with Y, IR Z by 2. From this IS, if I send IR that side, it will be IS is equal to IR, it will become plus, right? Plus YVR plus Y IR Z by 2. Okay, here IS is equal to, I am taking YVR other side and IR common. So this will become 1 plus here it will be YZ by 2. Right, consider this as equation 6. See, equation 1 again rewriting I am here. Vs is equal to Is Z by 2 plus V1. This is equation 1. Equation 2 is V1 is equal to VR plus IR Z by 2. So here what we can do is, see, we have Vs values here. V1 is also there. So just substituting this V1 in the place of like V1. You will get it like complete thing. Vs is equal to VR. This one I am writing here. And that will be IR Z by 2 and IS Z by 2. This IS Z by 2. In the place of V1 we wrote this whole thing. That's it. Okay. You got this Vs. Consider this as 7th equation. This is important. You got it, right? Now, see. You have, Is value we got here. 6th equation. And here also we have Is value. This whole thing you have to substitute over here. Okay. Just writing. Substituting equation 6 in equation 7. Alright. So, just simplifying it, Vs is equal to VR plus IR Z by 2. Is this whole thing, okay, into Z by 2, okay. This whole thing we have to write. Plus YVR plus IR, okay, IR 1 plus YZ by 2 into this whole thing into Z by, whole thing into Z by 2. Okay. So what you will get, I'll just see this in your all-in-ones and all he gave directly. Okay. I'm here simplifying each and everything so that it will be clear for you to understand. Okay. Now see. VR plus IR Z by 2. This is as it is. Now check here. This whole thing is into Z by 2. That means YVR Z by 2. YVR Z by 2. Plus, see this thing, IR is only multiplying with this one and into Z by 2. So this will be IR into 1 is IR into Z by 2. Z by 2. Plus, this one is IR. Y, here Z is there. This is multiplying with this one also. So z square 2 into 2. Remember this. This you people will not write. 2 into 2 is, this is 4. Alright. So now if we take here VR common, I'll take VR common. So this is 1. Here also there, yz by 2. And if I take IR common here, that will be z by 2 plus this one also z by 2 plus this will be yz square by 4. Right? Here I took IR common, z by 2, yz square by 4. Right? From here, I'll show you. So, you will write as, this will be as it is, 1 plus yz by 2 plus IR. So, see, this is 2z by 2 here plus yz square by 4. Alright. So, this will become, you can write it like this one. Okay, this will be cancelled. So, we have VR 1 plus yz by 2 as it is plus IR z plus yz square by 4. If you take VR yz by 2 as it is, IR, and I am taking z also common here. Alright, so this will be 1 z is already here. So this will be yz by 4. This is how you will get it. There in your books and all, he wrote this directly. I have showed you clearly over here how you got this line. So this is considered as equation 8. This is Vs is equal to. Okay, you got this right. So this is equation 8. Vs value. And in equation 6 I'll write one more time. Equation 6, check back once again. That is 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 equal to YVR plus IR 1 plus YZ by 2. This was equation 6. Check that, okay. So from these two equations, you got Is and Vs values. That means sending voltage and sending currents. So this it is in the form of, see, any two-port network, it will be AVR plus BIR. It is like that only, right? Vs, VR, A value is this one, IR, B value is this one. This whole thing, okay. Similarly, Is is equal to CVR plus DIR. So according to this, C value is Y and D value is this whole thing. Okay. Understood? This is for two-port networks. This is the format which you should get. We got it, both the equations. So from this, A value is 1 plus YZ by 2. B value is this whole thing, Z into 1 plus YZ by 4. C value is Y. D value is 1 plus YZ by 2. So this is D value. This is how you will derive ABCD parameters for a nominal T network. I hope this is clear. This is how you have to derive. I know this is a little bit tricky, but once you have known the circuit diagram, just by applying KVLs and KCLs, you can derive this whole thing. This is very easy. Remember the diagram, automatically you can derive the whole expression. I hope this is clear, and I hope this is useful also. And always remember these points before you start writing about ABCD parameters. Remember these few lines, whatever I have said, this distance and operating voltage and all. If you write this and start this, I think it's enough, and you'll get perfect marks, I guess. Okay. So this is also asked previously, December 18 in 2018 and 2017 also. Probably he will repeat it one more time. If you have understood this and you have got this question in the exam, then you will be lucky. I hope this is very, very clear. If you have any doubts, or if there is any mistake while doing in this one, if I have missed anything or anything, please let me know in the comment section. I'll be anytime available to clear it out. And if you need anything else also, please let me know. Thank you. Take care. Bye.